Increasing the number of consumers in a Kafka consumer group does not inherently increase the speed of message consumption unless the number of partitions in the topic is also increased. This limitation is rooted in Kafka's partitioning and consumer group architecture. Let's dive deeper into why this is the case. 1. Partition to consumer mapping. Kafka topics are divided into partitions, which are the smallest unit of parallelism in Kafka. Within a single consumer group, one partition is assigned to only one consumer at any given time. A consumer cannot process multiple partitions concurrently, but it can handle messages sequentially from the assigned partitions. If the number of consumers exceeds the number of partitions, the extra consumers will remain idle as there are no partitions left to assign. 2. Parallelism defined by partitions. Partitions determine the maximum level of parallelism. For example, a topic with 4 partitions can support up to 4 active consumers in a group. Adding a 5th consumer would not increase throughput, as only 4 partitions are available for processing. The number of partitions in a topic, not the number of consumers, defines the upper limit for concurrent processing within a consumer group. Narrative 3. Idle consumers add no value. Consumers that cannot be assigned a partition contribute no additional processing power and only consume system resources. Kafka's design ensures that partition ownership is exclusive within a group to avoid data duplication and maintain processing order. 4. Message order preservation. Kafka guarantees the order of messages within a partition. Allowing multiple consumers to process the same partition would break this order. To preserve order, Kafka ensures that only one consumer in a group can read from a specific partition at a time. 5. Scaling through partitions, not consumers. If you need to increase the speed of consumption, the solution is to increase the number of partitions, not just the number of consumers. Adding partitions increases the parallelism, as more partitions can be distributed among more consumers. Kafka's scalability is designed around the partition count, which is why increasing consumers alone has no effect once all partitions are assigned. Number 6. Optimal resource utilization. Increasing consumers without increasing partitions leads to inefficiencies. Underutilized consumers. Extra consumers remain idle. Wasted resources. Each idle consumer consumes memory, threads, and network resources without contributing to processing. Example scenario, partitions. If there are 3 consumers in the group, each consumer is assigned one partition. Adding a 4th consumer will result in the 4th consumer being